Hi Year 7. So we've been looking at arrays. For example, 5 2s is 10, 3 4s is 12. Now we're going to have a look at some other ones. These are all rectangles. We're going to have a look at a special case of ones that we call square numbers. So for example here, this is 1 by 1. This is 2 by 2. 2 2s are 4. 3 3s are 9. 4 4s are 16. These are all square numbers. Can you see why we call them square numbers? 5 times 5 is 25. 6 times 6, 36. 7 times 7 is 49. It's getting big now, isn't it? 8 times 8. 9 9s are 81. And the last one that I've got made is 10 10s. You know, 10 10s are 100. So these ones are special cases because they're square numbers. We call them square numbers. And we have a special way of writing them as well. Let me get rid of all of these. So we use the word indices or powers of. That's the I and the O in BODMAS or BIMDAS, whatever, however you may have learnt it. But basically, if I write something multiplied by itself, so for example, say I had this 3 by 3, so it's 3 squares across and 3 squares down and a total of 9. I could say it's 3 times 3, which equals 3 squared. Yeah, I had another one. I had 9 times 9, which was 9 squared. Can you see that this little 2 here represents the two dimensions, length and width? And it tells me that it multiplies 9 by itself twice. If I had have had 4 cubed, I would have had 4 times 4 times 4. So the 3 tells me that I'm going to multiply 4 by itself 3 times. So in the language of maths, this is what we call a base, and this is what we call the index. So you may have heard of these before. So that's what we're going to look at today. So, and sometimes we write out the numbers as a basic numeral. And you could work out 4 times 4 times 4, which is 16 times 4, 32 times 2, which is 64. So we have a base and an index. We can write it in expanded form. This is called expanded form. And this is just called the number or the numeral. The number. Yep. So we're going to do some problems with those sorts of things now.